Okay, so in 2.5 continued, we're going to be modeling data using lines of regression. Um, in the previous video, we learned that you could use 2 points to write a prediction equation, but your 2 points are not always going to give you the most accurate equation. So the most accurate one is going to be come from doing a line of regression, and that is actually used by very complex calculations that are done on the calculator. So we're going to be using an online calculator today to be writing our equation. So this table that I have here, we're going to be plugging it in to an online calculator at Desmos.com. So I'm going to go to Desmos.com /calculator. And from there, we're going to be inputting this table of data. So let me go ahead and show you that right now. We're going to Desmos.com /calculator. And here, while I'm on Desmos.com, when you want to input data, you're going to go to your little plus sign here on the left. And then from your plus sign, you're going to click on table to create a table. So once you get there, you can start inputting your data. So I'm just going to input the data that was on the table that I showed. Let me actually bring up that table so you can see where I'm pulling my data from as well. Okay, so here I'm just inputting this table of numbers. So I'm going to leave my X1 and Y1 there, and then I'm going to input my years. So I have 1980, 1985, 1990, 1995, 2000, 2005, and 2010. If you notice, next to 2010, they actually don't give the population. So I usually don't want to put that point in. If you do though, it should still work with the Desmos, but there's some calculators where it won't work. So next I'm gonna put my population, 4.451, 4.855, 5.295, 5.719, 6.124, and 6.515. So now that I've input all my data into my table, I can actually come up with an equation. So I'm going to go back up here to my plus sign. And to do the equation, you're going to click on f of x expression. And then here, you want your equation to be y equals mx plus b, slope intercept form. But instead of y, we're going to use y1 like it has here in the table. So y1, instead of equals, we use a squiggly line. If you do shift apostrophe, usually it brings that up. So shift apostrophe on a laptop will bring up that squiggly line. And then mx1 plus b. So it's like y equals mx plus b. It's just, sorry, I should say x1. It's like y equals mx plus b. It's just we're using x1 and y1 because that's from our list of data here. And you'll notice here it even gives you a slope and y-intercept. So I'm going to go ahead and show you how to look at the line of fit nicely here. So once I have it here, I'm going to click on this little anchor or this little tool on the right where it says graph settings. So sorry if you click there. It says graph settings. And then from there, you can actually mess with your X and Y axis. So if you look at our X values, they go from 1980 to 2005. I usually want it to start a little earlier and a little less. So I can start at like 1975 and end at 2010. There's no right or wrong way to do it. Your step is how much the years go up each time here, so I would want them to go up about 5. For my y's, you can see these range between like 4 and 6. So I can go from 4 to maybe 7. And I can go up maybe 0.5 each time. Again, there's no right or wrong way. You're choosing your parameters here. I can even go up 0.25 if I want. So once I set those settings for the X and Y axis, you'll be able to see your graph nice and neat. So here I can move it a little, but you'll see that this is going up. So I know that it's a positive correlation. You see the points are real close, so that I know that it's a strong correlation. So I'm gonna go ahead and for now, I'll come back to this later, but we're analyzing our graph. We can see that it's strong positive correlation. So on our assignment, it did ask to describe the correlation. We already used the calculator to make the scatter plot. Now we're describing that correlation. We said it was a strong positive correlation. Question B here wants us to find the equation of the line of regression and use it to write a prediction equation. So here we actually already did that. I'm going to pull it up right now, but we're going to have to write down that slope and y-intercept that it gave us so that we can write our prediction equation. So now if we look back at the Desmos calculator, here we can see the slope and y-intercept. So where I did my equation down here, they give me an m and a b. That's my slope and y-intercept. So my slope is equal to about 0.083. My y-intercept is about negative 160.18. I want to use as much decimals as possible to maintain accuracy. So I'm going to go ahead and use this to write down my slope and y-intercept. So the slope was 0.0831486. The y-intercept was about negative 160.18. And I got that straight from the Desmos where it gave me the m and the b. Now that I have that, I can write my prediction equation. So we're going to be using now the y equals mx plus b. We're plugging in for m and b, just like what we did in the previous topic. So my equation could be y equals 0.0831486 x minus 160.18. This is going to be a very accurate equation because instead of choosing 2 points from the data, this equation is actually using all the points and coming up with the best line of fit. So now we're going to use our equation to predict the population in the year 2010. So I'm going to plug 2010 into my x, because if we look back here, x was the years, y was the population in billions. So for x, I'm plugging in 2010. On a calculator, I can multiply 0.0831486 times 2010 comes out to about 167.12886 minus 160.18. So if I subtract 160.18, I get 6.948686. I want to make sure my answer makes sense. So here in the year 2010, I'm gonna be consistent. So here they're using 3 decimals. So I would use 3 decimals. Since the number after 8 is big, I'm gonna round up. So I'll put 6.949. And that would be the population in billions. So I could say in 2010, the population is 6.949 billion. So I'm just answering using words because it is a word problem. Again, all we did here is we used the Desmos. So instead of graphing by hand and writing the equation by hand, I use the Desmos calculator. I'll review those steps quickly one last time. So let's go ahead and look at how we did this. So what I did is I went to desmos.com/calculator. I started by clicking on the plus sign and I inserted a table. On your table, it has X1, Y1. You could include your data there. Then I went back to my plus sign and I hit F of X to type in an equation. When you type your equation, you're going to put Y1. Instead of equals, you put the little squiggly and then mx1 plus b. So it's kind of like y equals mx plus b. And then you can look at your slope and y-intercept there to write your equation. So your m and your b. I also went to graph settings and I use that to adjust the X and Y axis. Again, you're just looking at your table, figuring out where your X starts and ends, your Y where it starts and ends in order to do that. That way you can see your line of fit nicely. I did include a tutorial in the Google Classroom. So if you're stuck on these steps, if there's a lot, in the Google Classroom, you can go to the tutorial page that I uploaded. I'll show it here, but you would find it in your Google Classroom. But I did include a Desmos tutorial, and that tutorial just goes through these step by step. It even has you practicing typing a different table of data in and coming up with the equation for that data. So right now, I would suggest that you go pull up the tutorial, that you use it to practice with the Desmos. That way, when it comes time for you to do your assignment, you're already good at plugging these in, and you'll just have to worry about looking at your data, determining if it's positive or negative, weak or strong, and writing those prediction equations.